So what will happen is at the time t, its velocity has become some v, let's say like this. So this is going to act like a v cross v is pointing upwards, so it will act like a battery like this and a resistance. So this EMF will be BLV. So the current in the circuit will be BLV divided by R. So the magnetic force acting on this rod will become how much?
VIL.
VIL. So accordingly, just a minute.
V square L square into V by R.
So on the rod there will be a magnetic force which will act like this, creating a deceleration while it's moving with an acceleration like this. So this magnetic force is ILB, so it will be P square L square by R times. So the acceleration, which will actually become minus dV by dt, will become B square L square by mr times V. So you integrate this and you get that expression. dV by V is equal to minus of P square L square by mr times dt. ये 0 to t जा रहा है, ये initial velocity v0 to v जा रहा है. So you'll get that kind of expression that v is equal to v0 e raised power minus t by tau, where that tau will be mr upon
V square L square.
p square. That is the full explanation of this question. So that thing is missing actually.
Sir,
So rest is okay ना in this question?
इसमें वो रेजिस्टेंस का यूज कहाँ आया जो नहीं दिया हुआ है?
नहीं, उसके बिना सर्किट नहीं कंप्लीट हुआ ना बेटा. If you just have these two rods,
ठीक है.
and this rod will act like a cell and a resistance, okay, but circuit will not be completed, so there won't be any current. In this situation, there won't be any current, so it will just go without any magnetic force. Understood now?
Yes.
So एक और situation हो सकता है कि the rods are infinitely long, the horizontal rods, no? These two, if they are infinitely long, then you can assume, okay, somewhere this side they are going to infinity where the potential is 0. So that can be assumed like a closed circuit because they are infinitely long. But better than that is if they are just given some rod over here or some wire over here. Okay. So rest of the question is okay, right? That work energy part you can do. I square R वो integrate करना पड़ेगा है ना? Total heat. Okay. Then next, which one we are doing, beta? 24, 25th ये.
तो उसमें 25th में बस वो R जो है कैपिटल वो सीरीज में क्यों है?
Okay. 25th में. Okay. So इसको क्या करें? We have to make an equivalent circuit. So what is happening is that you have in this 25th question, each side में we have a resistor R1. At the other end we have a resistor R2. And these are joined by again those rods kind of things which are of negligible resistance. Okay. And in between you have that thing, okay, this thing, which is moving with velocity v and it has a resistance capital R and there's a magnetic field going into the plane. So इसका equivalent circuit कैसा बन जाएगा? Magnetic field is into the plane, so this will again act like a battery like this, okay, and resistance capital R like this. So this is your equivalent circuit. R2, R1. ये हो गया ना बेटा? Now understood now? So this current is I. It will split into I1 and I2. It's a parallel combination. So your equivalent circuit is like this thing. R1 parallel R2 in series with R and the cell. So this is your I. So is it clear, beta?
Yes, sir.
And that EMF will be BL. So now it is just BLV divided by capital R plus
R1 R2 upon R1 plus R2.
yes. So this will become R1 R2 upon R1 plus R2. If you want to find the individual currents, then you can put this current in this equation and
BLV KVL.
KVL. Okay. So this is clear.
Yes.
24th is clear, no? Okay. Then next, this 23.46. This one. Okay. You have to find the Q value in the reaction. So इसमें क्या है देखो mass is given for both sides. No? So Q value of the reaction क्या हो जाएगा? Mass defect into C square.
Yes.
So whenever we have a reaction in which we have to find the Q value, 23.46. This one, 17 plus P. So इसमें this one's mass is 14.00307 atomic mass units. This one's mass is alpha particle is the helium particle, helium nucleus. So it is 4.00260. Similarly, इसका mass दिया हुआ है, इसका mass दिया हुआ है. So what you do is you find the Q value as delta M into C square. So that is mass of N14 plus mass of the alpha particle minus mass of oxygen 17 isotope plus mass of that proton. This into that 931.
930. Okay, sir. Okay, sir. I was multiplying by C square actually. इसलिए नहीं आ रहा था.
So वही होता है ना, when you take delta M in atomic mass units, it becomes the delta M into 931 million electron volts. That kind of thing. Okay, so this is clear, better?
Yes.
Any names in this set?
So 23.49 as well.
Okay, so इसमें क्या करना है? You have a sample of hydrogen gas, 100 atoms. All atoms are excited to nth state. Total energy released is so much. Okay. As they come to the ground state. Find then the maximum energy of emitted photon. So this you found out, the 23.48 part.
Yes, sir. That I got.
उसके लिए क्या किया for the maximum energy of photon? उसके लिए भी तो
जो 4800 पे 49 दिया उसको 100 से डिवाइड किया.
Okay. So 48 by 49. Okay. Into 13.6. Correct? तेरा maximum energy of photon हो गया. ये delta E max है. Correct? This is what you done ना बेटा?
Yes, sir.
ये energy कहाँ से आ रहा है? This is coming from this ना 13.6 1 upon 1 square minus 1 upon n square.
The n is equal to 7.
So n square minus 1 upon n square is equal to 48 by 49. So इससे n 7 आ गया. So which excited state it is? It's the sixth excited state. So actually this is n equal to 7. मतलब this is the E6 because ground state is n equal to 1. First excited state is n equal to 2.
Yes, okay.
So this is the sixth excited state. So this is actually sixth excited state. और quantum number equal to 7. ठीक है, वही डाउट था तेरे को?
हाँ वही 7 आ रहा था, 6 नहीं, वो समझा मैं.
भी केयरफुल हाँ कि n को कैसे डिफाइन किया है. एक्साइटेड स्टेट डिफाइन किया है कि वो डिफाइन किया है दी क्वांटम नंबर. principal quantum. Okay, Arman, so this is clear, no?
Yes, sir.
Next one is this eighth question, coaxial cable. Okay. So two very thin walled conducting cylinders. Okay. So these are like cylindrical shells, because thin walled bola hai, of radius R1 and R2. I going in one direction, I coming in out. So show that B is 0 except in the region between the two. Okay, so this is like this, no? Ampere's law we use. So in this, if you take the cross section of the cylinder, so this is the inner shell, which is very thin. Like this, we have an outer shell also, which is also very thin. ठीक है, so अभी इसमें क्या हो रहा है that suppose current is coming out of this one, the outer one. So the current density vectors, you will see them as dots coming out, and that total current is I. Okay, so total current I spread out uniformly like this, coming out of this. And in the inner one, then current is in opposite sense, so it will be going into the plane. ठीक है ना, Arman, this is clear?
Yes.
So now, if you draw an Amperian loop like this over here, in this region, and we take V dot dl in the clockwise sense, radius R. So for this loop, R is between the inner one's radius and the outer one's radius. So for this loop, what will happen? Our integration d dot dl will become mu naught I. Okay. I is going into the plane, so this is clockwise. So b into 2 pi r will become mu naught I. So b will become mu naught I upon 2 pi r. But that is for this region between capital R1 and R2. Okay. But similarly, if we take an Amperian loop, which is let's say like this one, in this region, इसके लिए नेट करंट एनक्लोज कितना हो जाएगा? 0 हो जाएगा, है कि नहीं?
क्योंकि opposite directions में हो जाएगा.
Because opposite direction. So R prime greater than R2 अगर ऐसा लिया, so in this what is happening? Mu naught is becoming I minus I. So this is going into the plane, coming out of the plane. So your d dot dl integration will be 0. And there is radial symmetry. So this actually means b into 2 pi r is 0. Okay. So that means b becomes 0. And similarly in the inner region. So there's magnetic field only between those two shells. What is beta? This clear?
Yes.
Okay, next This one 23.29. इसमें डाउट है ना बेटा?
हाँ.
A and B, the area enclosed by the nth orbit in hydrogen atom. Then graph of ln En by E I against ln N. तो ये तो उसमें है ना बेटा, रेडियस कैसे वही करता है क्वांटम नंबर के साथ, प्रिंसिपल क्वांटम नंबर के साथ. रेडियस ऑफ ऑर्बिट का फॉर्मूला याद है बेटा?
Proportional to n square.
हाँ, प्रोपोर्शनल टू n स्क्वायर ना. अभी उसको ही प्लॉट करना है. Just write this formula. The radius of the nth orbit is r0 into n square, no? But here again the thing is, we are talking about excited state, or we must be talking about this thing only, principal quantum number. Because zero नहीं हो सकता है, ठीक है, तो हो जाएगा ना. So area will become n to the power 4 pi r0 to the power 4. So ln of an by a naught or whatever, you can calculate this. ठीक है बेटा, understood? Arman, understood this, no?
Yes, sir.
Okay. Then next thing is which one? Alpha decay. This one, right?
Yes.
The alpha decay of kinetic energy of alpha particle. In an alpha decay, the kinetic energy of alpha particle is this much, and Q value is this much. Mass number of the mother nucleus will be how much? Okay. तो इसमें क्या हो रहा है ना कि if you have some, let's say, nucleus of Ez, which is the mother nucleus, okay, it in alpha decay it will become E minus 4 Z minus 2 plus 2He4.
Yes.
Now what you assume is that the mother nucleus was at rest to begin with. So X was at rest, and then it gave you Y plus that alpha particle. So if this was going at speed v1, this will recoil at speed v2. So that momentum of the system should be how much? 0. What now?
Yes.
So इसका mass जो होगा 4 times atomic mass unit होगा approximately, और इसका mass कितना हो जाएगा? Capital A minus times atomic mass unit. Okay. So 4 times v1 must be equal to A minus 4 times v2 is equal to some linear momentum P, let's say. This is conservation of linear momentum, this equation.
Yes.
So that's your equation 1. And now your Q value of the reaction will be equal to the kinetic energy of these two only. Because और कुछ यहाँ पे liberate नहीं हो रहा है. There is no photon, anything. So the Q value is nothing but P square by 2 times mass of that daughter nucleus plus P square by 2 times the mass of the alpha particle. Okay. So this thing, तो अभी क्या दिया हुआ है मुझे?
Kinetic energy of alpha particle दिया और Q value दिया.
हाँ, is equal to P square by 2 times, इसको मैं क्या लिखूंगा? A minus 4 in atomic mass units, okay, plus P square by 2 times 4 atomic mass units. So ये जो kinetic energy है, kinetic energy of the daughter nucleus plus kinetic energy of the alpha particle, इनका ratio मिल जाएगा मुझे in terms of this thing. So this is 48. This is given as 48, right? Alpha particle. So this is, so if this is 48 MeV, that means this is 2 MeV.
Yes.
So kinetic energy of alpha particle is to kinetic energy of this thing. The daughter nucleus is 48 by 2 or 24. Now kinetic energy of the alpha particle is that linear momentum p squared divided by 2 times 4 atomic mass units, and this is p squared divided by 2 times a minus 4 atomic mass units. Okay. So that is 24. So e minus 4 divided by 4 is equal to 24. So e is becoming how much? 24 into 4, that is 96 plus 4. So 100. So capital A, which is the mass number of this one, must be this much. This is how you solve a question like this.
Okay, sir.
Right. Okay. Next, we are doing which one? This 13th question, inductance wala.
Sir.
Okay. Yes. So you have this cell, distance small r, switch S1, another switch S2. Resistance capital R, inductance L. All these points are labeled. Okay, now in the circuit shown, the current I0 is 4 amperes when S2 is closed and S1 is open. Okay, so at some instant, S2 is closed and S1 is open. So at that point of time, let us say your equivalent circuit becomes like this. So if the current is like this at that point of time, then L di by dt and IR should be 0. Okay. But the polarity is also shown like this. So ठीक है. So di by dt will be a so at t equal, so this will give us what? This will give us that kind of relation that I is equal to I naught e raised power minus t by tau, where tau will be L by R. Understood, Narman? Arman, this is clear, beta? this circuit na is just given for confusion. Actually क्या हो रहा है, decay circuit ही operate कर रहा है.
हाँ
Point बेटा, मतलब what must have happened is कि मैंने S1 को closed रखा होगा for a long time so that this circuit reaches steady state, the charging circuit, and then at t equal to 0 I've switched, S1 को open कर दिया और S2 को close कर दिया.
Okay.
So the discharging circuit is operating. So that point of time this becomes variable, and the total heat dissipated will be the initial energy of the inductor, which is half Li naught square.
Okay.
So these are the equations you can directly use now. ठीक है बेटा, the question is clear?
Yes, sir.
Okay. Next one. Okay, let's look at this one. 20-second, right? This long straight wire one.
Sir, I have a doubt in this.
हाँ बताओ.
जो I square R वाला पार्ट है,
हाँ
जो A पार्ट है वो मेरा आया, और तो B पार्ट के लिए उसको इंटीग्रेट नहीं करना होगा.
हाँ इंटीग्रेट कर सकते हैं, बट सी अल्टीमेटली लॉजिकली भी नो क्या होगा ना, इसमें जो एनर्जी स्टोर्ड है वही हीट में डिसिपेट हो जाएगा.
तो डायरेक्टली ये लगा के
इंटीग्रेट I square R dt from t equal to 0 to t tending to infinity, you will get that only. This will become I naught square R e raised power minus 2t by tau dt from 0 to infinity. So when you do this integration, this will come out to be half Li I naught square.
Okay.
Yeah. Alright, this is clear, beta?
Yes.
Okay. Now in 20-second question, beta, tell me what you tried. You have this infinitely long straight conductor, which is carrying current I like this or whatever, I not like this. और उसके बगल में we have this circuit which basically consists of something like a rectangular.
इंटीग्रेट करने का ट्राई किया तो नहीं आ रहा था मेरा से.
Okay, I'll explain. No, वही करना है. You have to do that only. So what is happening is na, that your moving rod is in a, so this thing is in a variable magnetic field. So we have to integrate this. So this is moving with a velocity v. Okay. तो यहाँ पे जो magnetic field lines है वो ऐसे दिखेंगे. Sorry. हाँ, ideal is going into the plane here. So the density of these field lines will be decreasing as you go away from the wire. Just like this. So what we'll do is we'll take, say, at a distance x, we'll take an element of thickness dx. So that element will behave like a differential voltage source. Now, V cross V is pointing like this. So that differential voltage source will be equal to B as a function of x into V into dx. So B as a function of x will be mu naught I naught divided by 2 pi x into V dx. Right, beta?
Yes.
So your EMF induced will be this. So mu naught I naught V by 2 pi dx by x को कहाँ से कहाँ इंटीग्रेट करना है. ये वाला डिस्टेंस a है और ये वाला डिस्टेंस b है. So a to b, तो ln b by a आ जाएगा ना.
हाँ.
x equal to a to x equal to b. So your EMF induced will be mu naught I naught v by 2 pi into natural log of B by A. This will become your EMF induced. And then divide that by resistance, you'll get the current induced. ठीक है बेटा, this question is clear?
Yes.
Force required will be BLV. मतलब उसको भी इंटीग्रेट करना पड़ेगा, है ना, बिकॉज ILV को भी इंटीग्रेट करना पड़ेगा. अंडरस्टूड ना? Now your current induced in this, so like that. So the current induced will be this EMF induced divided by R. And now for the force also, what we'll have to do is
BIL integrate.
Correct. We'll have to take at a distance x. We'll have to take an element like this. So I dx is going up and B is into the plane. So magnetic force acting on it will be like this. So IB dx. उसमें यही value of B लाना पड़ेगा. I into mu naught I naught divided by 2 by x dx. So your magnetic force will become mu naught I naught upon 2 pi dx by x, again integrated from x equal to 0 to x equal to a to x equal to b, where your I will be this thing, E divided by R. So mu naught I naught by 2 pi R. So ये ln b by a वाला टर्म स्क्वायर में आ जाएगा. अंडरस्टूड ना बेटा? Is this clear बेटा?
Yes.
Next, what do we have?
So 23.31.
Just a second. 23.31. Okay. De Broglie wavelength of a molecule varies inversely as the square root of absolute temperature. So how we can make that statement? Relation between de Broglie wavelength and temperature. So kinetic energy, or P square by 2m for the molecule, is proportionate to Boltzmann constant into temperature.
Yes.
Okay. So linear momentum is proportional to square root of temperature. So lambda de Broglie is h by p. No?
Inversely proportional to root T.
So RMS velocity of a molecule depends on temperature. Yes, that's the correct reason.
So it should be A now.
You can say like that. Ideally, it should be that RMS velocity is proportional to square root of temperature, because VRMS is proportional to some factor into root T. No?
Yes.
But it depends on temperature, so that's why de Broglie wavelength also depends on temperature.
Answer given is B. He is not related नहीं है statements.
Yeah, so the thing is, it says that it depends on temperature, but it does not say why it is dependent upon 1 by root T. ना? मैं सिर्फ बोलूंगा टेम्परेचर पे डिपेंड करता है. So can I determine the relationship? नहीं ना? So that's why probably that. थोड़ा सा ambiguous है, but ठीक है.
Yes.
Okay, then this one, 23.19.
Yes.
So 1.5 megawatts of 400 nanometer light is directed at a photoelectric cell. 0.1% produce photoelectrons. The current is how much? So इसमें क्या करना है? See, power is given to us in megawatts. Power is 1.5. Okay, so that is 1.5 into 10 raised power 6 watts or joules per second. ठीक है. So इससे हम क्या निकालेंगे? Photon flux. energy of a photon hc by lambda. So that is approximately how much? 1400 होता है divided by 400 in electron volts.
Yes.
Something like that, approximately. Okay. So anyway, so the photon flux, let's see, n, that is number of photons incident per second. Per unit time. That will become this power divided by energy of photon. So it is 1.5 into 10 raised power 6 divided by hc by lambda. Okay. So now what is happening? The electron flux वो कितना हो जाएगा? It will become photon flux into that probability factor. So that is 0.1%. So it will be 1.5 into 10 raised power 6 divided by hc by lambda, okay, into 1 by 1000. Okay, but this is clear? Okay. So now your photo current will be charge per unit time. So it is electron flux multiplied by charge of electron. You know, because this is number of electrons per second. ये जो पूरा चीज है वो per second है. So many electrons are getting, conducted per second. So photo current will be this thing. Into 10 raised power minus 3 into electronic charge. Now the thing is, this thing when you substitute, you'll have to convert this to joules. Okay. So that will become the energy of the photon in electron volts multiplied with E. So that E will cancel. Is it clear, man?
Yes, sir.
Okay. We can complete this calculation. Okay. That is that. Okay. Then next is which one? The seventh one, no?
Yes.
Okay. So rectangular loop of 10 by 5 with resistance this much, just pull through.
क्या आप एक थोड़ा ऊपर कर सकते हो?
हाँ बेटा.
स्क्रीन को थोड़ा ऊपर कर सकते हो सर?
हाँ. Okay, beta, done.
Yes, sir.
Okay, now next is seventh question, no? This EMI one.
Yes, sir.
So what is the difficulty coming in this, beta? See, क्या हो रहा है? T equal to 0, it starts entering. So that point of time there will be induced current, no? Till the loop is fully inside.
Yes.
Because rate of change of flux is there, no? Or you can think of it like this, that the vertical rod which is inside the magnetic field, that is having induced EMF, but the other one is outside, so there's no induced EMF. So loop का net EMF कितना हो रहा है? BLV. है ना, while it is
हाँ हाँ
entering.
हाँ सर, ये ऐसा क्वेश्चन एक किया था, हाँ हो जाएगा ये।
सेंस ऑफ करंट कैसा होगा, फ्लक्स कमिंग आउट इज इंक्रीजिंग, सो क्लॉकवाइज होगा,
हाँ
ठीक है. Then what happens at t equal to 5 seconds, the loop is fully inside.
यस
Because that distance 10 centimeters divided by 2 centimeters per second. So when it's fully inside, what will be the net EMF? Zero हो जाएगा,
यस
because दोनों vertical part inside है ना, तो yeah, flux is not changing anymore. Then it starts coming out at what time? It starts coming out at 20 divided by 2 or 10 seconds. So
यस
first 5 seconds there will be EMF induced. Then next 5 seconds EMF will become zero. And then another 5 seconds will be EMF but opposite sense.
ओके
You can understood?
यस
Okay. The next is which one? 27th one.
यस सर, in the previous question, seventh one, for
हाँ.
5 to 10 seconds, uh, EMF will be zero.
The net EMF of the loop will be zero. You know, because by Faraday's law, the flux is not changing. By motion generated EMF क्या हो रहा है? दोनों जो vertical rods हैं, they are acting
हाँ
like batteries, but उनके polarity opposite sense में हो जाएंगे,
हाँ,
है ना? So that's like, so they are cancelling each other's EMF.
आंसर उसमें 5 to 10 seconds के लिए दिया है 5 into 10 to the power minus 3.
क्या दिया हुआ है?
For 5 to 10 seconds, answer given is 5 into 10 to the power minus 3 EMF.
And what is the EMF for 0 to 5 seconds?
10 to the power minus 3 into t.
Wait. मतलब in the graph it is shown like that.
उसने ग्राफ में मैंने उसने वैल्यूज लिख दिए हैं टाइम इंटरवल्स के लिए.
So 0 to 5 it is given as
10 to the power minus 3 into t
into B.
into t time.
EMF की flux.
Flux.
हाँ तो वो ठीक है ना बेटा. फ्लक्स तो देखो जीरो नहीं होगा ना, फ्लक्स कांस्टेंट होगा ना, इट विल बी एरिया इनटू मैग्नेटिक फील्ड.
अच्छा हाँ हाँ ठीक है
Right
ठीक
now,
है.
because the flux is increasing with time, so that's why it's directly proportional to time.
यस
So EMF is what? Rate of change of flux ना, तो उसको differentiate कर तो आ जाएगा EMF.
हाँ ठीक ठीक है.
Then as it is fully inside, the flux becomes constant.
यस
So that's why EMF is zero.
यस
So that's why they've given, because they have given the value of flux, not the value of magnet of EMF. Is it clear now?
यस.
Okay. So then next this 27th one.
यस
Okay, so ये length दिया हुआ है 1 meter, R1 R2 connected है, horizontal magnetic field नहीं, mass दिया हुआ है, there is uniform magnetic field 0.6 Tesla. It is observed that when the terminal velocity is achieved, the power dissipation in R1 and R2 are this much and this much. Find the terminal velocity of the bar. ठीक है? So have you understood the question बेटा, इसमें क्या हो रहा है?
यस.
Why don't you terminal velocity? Because some stage the weight will get balanced by magnetic force. So this falling rod, these two are vertical rails like this. And in between we have the resistance R1. very far below you have resistance R2. Now, iske beech, when my rod is somewhere in between, so let's say at some point of time, this rod has a velocity v, and there's a magnetic field going into the plane which is v. So v cross b will be in this sort of direction. So this will be acting like an EMF like this. So there will be a current I like this. So that EMF will be VLB. So that current I will be E into 1 by R1 plus 1 by R2. Okay. So this will be your current. So your magnetic force acting on it will be ILB, and this will be current. Where this current is I1 and this current is I2. So your acceleration will be mg minus magnetic force divided by mass. So when terminal velocity condition is reached, acceleration is 0. So mg should be equal to fb when the velocity is equal to terminal velocity. So mg should be equal to ILB when v is equal to terminal velocity. So mg should be equal to BLB divided by R1 R2 R1 plus R2 in the terminal velocity condition. Okay. And at that terminal velocity condition, your I1 will be equal to BL into V terminal divided by R1, and I2 will be divided by R. This is at V equal to V terminal. ठीक है बेटा, these equations are clear?
Yes.
Okay, so this is done, beta, clear?
Yes.
Okay, next let's come to 29th question. Semicircular metallic rod है, radius दिया हुआ है, mass दिया हुआ है. Separation between them is 2r. Okay, and this is falling like this. So इसमें क्या होगा ना, in this question, in 19th question, you can replace the semicircular rod with an equivalent rod which is the diameter and have the same property. You understanding, beta? Between these two vertical rails, if you have any odd shaped conductor which is falling with a velocity v like this, okay, inside a magnetic field, this is equivalent to, if this length is L, it's equivalent to a rod like this falling with the same velocity v. How we can do this? By superposition. If you add the semicircular or any odd shaped rod, you add this with the straight rod, it becomes a closed loop. So net EMF कितना होना चाहिए? 0 होना चाहिए.
0.
What is it? So ultimately, this is the same question as a straight rod falling like that.
Okay.
So this is a trick that you can use in these type of questions. Okay, so this you can do now, beta.
हाँ तो ये होता है then
Okay. Now next is this modern physics question, no? Comprehension.
हाँ
Okay. इसमें क्या प्रॉब्लम आ रहा है? Pertain to the statement and the diagram. Energy level diagram for hydrogen atom. Several transitions are marked. In which transition is a Balmer series photon absorbed? तो photon absorb कब होगा बेटा? When there is excitation.
हाँ
और Balmer series कब होता है? When there is it
second
relaxes to first excited state or n equal to 2, है ना? तो अभी absorption होना चाहिए. That means n equal to 2 से लेके higher state जाना चाहिए. So that is happening in the sixth transition. You can see going from 2 to our higher state, ना?
हाँ yes
Right ना?
yes
Okay. Transition 2 में you have to find the wavelength, है ना? 2 कौन सा है?
I think 4 to 2 जो जा रहा है वो है 2
Okay. So that will have energy of how much? 13.6 into 1 by 9. Sorry, into 1 by 16 minus 1 by 4.
हाँ वही I'm not getting the answer I did that I think calculation error हुआ होगा तो
हाँ, 13.6 into 1 by 4 square minus 1 by 2 square should be equal to hc by lambda. और इसमें substitute hc as that 1,
1240
हाँ, 1242 electron volt nanometer, ऐसा ना?
हाँ
So you should be.
calculation error हुआ होगा
And which transition will occur when a hydrogen atom is irradiated with a radiation of this much? So again, you have to use this only, no?
हाँ HC by lambda ठीक है sir
मतलब थोड़ा painful calculation है इसमें.
हाँ
Okay. Okay. Next is this EMI question, no?
हाँ D part well
With the length of thin conductors, magnetic field is going into the plane. The field starts decreasing. Find how the currents induced in this loop. Okay, in D part. Okay, so in D part देखो क्या हो रहा है ना कि it's a very interesting situation. Your loop is like this, something like this. Okay, so abhi you see what is happening. This magnetic field is what, decreasing with time or increasing? Decreasing, है ना? So magnetic field is decreasing with time. So the flux into the plane is decreasing.
yes
ठीक है? So if flux into the plane is decreasing, then it should create clockwise sense by this thing,
yes
by Newton's law. Okay. So इसमें clockwise sense हो जाएगा ऐसा, but at the same time इसमें कैसा हो जाएगा anti clockwise, because the current is going like this. Okay. Now why it will be like this? Because the larger area will dominate over the smaller area. अगर उल्टा होता तो larger area के लिए it would start coming out.
हाँ
Understood ना बेटे?
yes
तो दोनों में से एक को कॉम्प्रोमाइज करना पड़ेगा. So कौन सा कॉम्प्रोमाइज करेगा? The smaller loop, because its area is lesser.
ठीक है sir
ठीक है, understood. That's the question. Okay, then next is this 29th question, no?
yes
Wire shaped as a semicircle rotates. Okay. Like this. So इसमें क्या होगा ना कि as this semicircular wire is rotating, you understand See, if you had a full circular wire rotating about this diameter, with omega, और इसका रेडियस सपोज कैपिटल आर है, तो इसका फ्लक्स कैसा होता है? द फ्लक्स वुड हैव बीन pi r square b, where b is, let's say, going into the plane or whatever, into cos omega t kind of thing, है ना?
Yes.
So your EMF induced would be br square, I mean pi r square b omega sin omega t, this kind of thing.
हाँ.
तो अभी हाफ है तो EMF induced, बट इसके अबाउट रोटेट कर रहा है. सो ये दोनों पॉइंट्स के बीच, लेट्स से दिस इज P एंड दिस इज Q, पोटेंशियल डिफरेंस जो जनरेट होगा Vp माइनस VQ, वो ये EMF का हाफ हो जाएगा. Should be how much? Pi r square by 2 b omega sin omega t type. It's an alternating current generator or alternating voltage source. E naught sin omega t type का है, where E naught is that area which is pi r square by 2 into b into omega. Is this clear, madam?
Yes.
That rotating semi loop, semicircular thing, it acts like a AC generator actually.
हाँ.
Alright, beta. So this is clear.
Yes.
Just a minute, but I'll just return. Next is this photoelectric wala question now. 23.42.
Yes.
Okay. Yeah, man. So that next question,
Sir, in this question, जो मीन निकालने के मीन थर्मल पावर निकालने बोला है,
कौन सा
ये 29 वाला.
हाँ, तो उसमें आरएमएस से कर सकते हैं ना, मतलब ई स्क्वायर बाय आर will become E naught square sin square omega t divided by R. Understood? So if they've asked to calculate in the rotation period, how much energy. Actually, power say they also mean energy, because they said in how much time in one rotation cycle.
Okay.
So it is this thing. So the energy liberated is the power integrated over time. So it will be E naught square by R sine square omega t integrated over one cycle, where capital T is 2 pi by omega. Understood, na beta?
Yes.
Basically, you can use that trick also, that RMS value of sine square is 1 by root 2.
हाँ.
So the sine square का average value half होता है. So this integration will actually be capital T by 2. ये जो पूरा इंटीग्रेशन है इसका वैल्यू कितना हो जाएगा, कैपिटल T by 2 हो जाएगा. तो साइन स्क्वायर का एवरेज वैल्यू हाफ. Shall we come to the next question? Photoelectric effect.
Yes, sir.
Yeah. So what's happening in this now? Photons of energy this much. Like kinetic energy is varying from 6 to 8 electron volts. Find the work function of the metal. Okay. अच्छा, तो अभी देखो क्या हो रहा है कि maximum kinetic energy of a electron reaching the anode is how much? 8 electron volts. So Ke max at the anode is 8 electron volts. So that means maximum kinetic energy when it is leaving the cathode, that is equal to how much? 3 electron volts, because the voltage of the cell is 5 volts. Okay, beta, this is clear.
Yes.
So this maximum kinetic energy at the cathode, this is equal to how much? This is the energy of the photon minus the work function. So that is equal to 3 electron volts. And energy of the photon is 5 electron volts. So 5 electron volts minus work function is equal to 3 electron volts. So that means my work function is equal to 2 electron volts. Okay. Is this clear?
Yes.
Now saturation current हो रहा है कि नहीं? नहीं हो रहा है ना, because there is a range of this thing. The minimum kinetic energy at the anode is 6 electron volts. So that means from that, how can we say whether it is in saturation state or not? Is the thing, no? Not sure whether we can state whether it is in saturation condition or not, because just from the range of kinetic energies, we cannot state whether the circuit is in saturated state. You can certainly see this much कि उसका energy of the photons is quite a bit more than work function. That is fine. और मे बी द लॉजिक दैट दे आर सेइंग इज कि जो 6 इलेक्ट्रॉन वोल्ट वाला निकल रहा है ना, जिसका काइनेटिक एनर्जी एनोड पे 6 इलेक्ट्रॉन वोल्ट्स है, उसका काइनेटिक एनर्जी कैथोड पे कितना है? 1 इलेक्ट्रॉन वोल्ट है. तो Not sure actually. It doesn't mean that it's saturation current. Where is this question from, beta?
The resonance guy.
Okay, I'll check if there's any other way. But as far as I can tell, you cannot really determine whether it's saturation current or not from this data. It's actually an experimental thing. Okay. Is the first part clear?
Yes. आंसर दिया हुआ बट 2h
दिया हुआ क्या है?
2 दिया हुआ है आंसर.
नो, मतलब नॉट सैचुरेशन करंट. हाँ बेटा.
क्या सर?
What is given in the answer?
आंसर गिवन इज 2.
That is fine. Work function तो आ गया ना 2 electron volts.
हाँ.
But
Current
what
is less than saturation current.
ऐसा दिया हुआ है less than.
हाँ.
Not sure how they've determined that. Okay, shall we come to the next one?
Yes.
This rotating rod, right?
उसमें सर C वाला part सर.
Okay, draw any radial line in the plane. Any radial line in the plane from which measure theta equal to omega t. Show that the area of the pie-shaped region between. Okay. So the meaning of this is, see, you just imagine that your rod has rotated through some theta. Okay.
Yes.
Because theta is equal to omega t. So rod यहाँ से यहाँ rotate कर गया है.
हाँ.
In some time. Suppose at t equal to t1 it was here. So at now time equal to t2, which is let's say t1 plus delta t, it has rotated through this angle theta. So that theta is equal to omega delta t like this. Or in this case they have taken theta as omega t. So ये जो area होगा जो rod sweep कर रहा है वो कितना होगा? Area of sector होगा. So this length is L. That area will be theta by 2 pi into pi L square, or theta by 2 into L square, where theta is equal to omega t. Okay.
अच्छा. हाँ.
Okay. So flux through this area is how much? B into this. So the flux is B into L square by 2 theta, which is omega t. So rate of change of flux is differentiation of that with time. Okay, but is this clear?
Yes.
Then which one? This 23.27, right?
Yes.
Applied voltage दिया हुआ है. The energy required to remove an electron from the L shell is 19.9. Okay. Okay, so minimum wavelength क्या होता है? Maximum energy. So hc by lambda minimum, that cutoff wavelength, is equal to what? Energy of the incident photon, na? But it is the energy of the this thing, incident electron. Understood ना अरमान?
Yes.
See, जो X-rays का जो ग्राफ होता है ना, उसमें ये continuous spectrum होता है, और फिर उसमें characteristic lines होते हैं, ठीक है ना? So energy versus lambda, ये जो lambda minimum है, वो characteristic नहीं होता है ना, वो continuous का होता है ना. So उसका ये है ना. So this is basically what? It is electronic charge multiplied by the voltage across the tube. So that in this case is electronic charge into 20 kilovolts. So into 20 into 10 raised by 3 joules. So it is 20 into 10 raised by 3 electron volts. This is clear. So your lambda minimum will come from this formula. It is independent of the z and all that. Now only characteristics के लिए it depends on that. So minimum wavelength यहाँ से आ जाएगा, ठीक है? And energy of the characteristic X-rays will be how much? Now see what is happening. Energy required to remove an electron from L shell is 19.9 kilo electron volts. So, and your maximum energy of the incoming electron is 20 kilo electron volts. So K shell से remove हो पाएगा क्या? नहीं ना?
क्या सर, एक बार आप रिपीट कर सकते हैं?
See, your K shell से इलेक्ट्रॉन रिमूव करने के लिए कितने एनर्जी की जरूरत है? We require that Z square into 13.6, right? This much energy. Whereas L shell से इलेक्ट्रॉन रिमूव करने के लिए कितने चाहिए? Z square into 13.6 by 4, है ना? So this is less than this, ना? Now this value is some 19.9, whereas the maximum energy we have is 20 kilo electron volts. So will that be sufficient to get the K shell electrons out? No, na? Understood?
Yes.
Because L shell के लिए अगर 19.9 है तो K shell के लिए उसका 4 times होगा. So that means K shells से electron निकल नहीं पाएंगे for this voltage. What? So
Yes.
that means energy of the characteristic X-rays will be either that 19.9 or less than that. Can't be more than that. Okay. And L alpha electron may be emitted, but L alpha electron कहाँ से कहाँ तक होता है? It is the electron that is emitted when you relax from L alpha is when you relax from n equal to 3 to n equal to 2. Okay. So it is not this 19.9 ना. ये 19.9 तो ये वैल्यू है. Whereas ये वाला जो है L alpha है, इसका hc by lambda is how much? It is 13.6 z square into 1 by
9 minus 1 by 9 minus 1 by 4.
So that's why option D is not correct. Is it clear, beta?
Yes.
Okay. Anything else?
No, sir.
So your doubts are clear, beta?
Yes.
Okay. How your study is going in general?
Good, sir.
Okay. So ठीक है, you continue with your work, beta. ठीक है?
Yes.
Today you have some classes and things, or?
No, no, only your class was that.
Okay, okay. ठीक है, so continuing some work. In case you have some doubts tomorrow, day after, you can just WhatsApp me. ठीक है?
Yes, sir.
Okay.
Thank you, sir.
Thank you.